Am I audible?
Yes.
I request
Yes, ma'am,
you, any of you, to kindly give me reply whether I am audible to you or not.
Yes, ma'am, we are audible.
Am I audible to you all?
Yes, ma'am.
Thank you. I would like to again thank you, welcome all of you. Now I would like to request Mr. Chaturvedi sir to kindly deliver his expert talk on our first session, that is electrical vehicle, its past, present and future. Please sir.
Okay, thank you, madam. Am I audible?
Yes, sir. Yes, sir.
All right. Okay. So just let me share my screen. I hope you can see the screen.
Yes, sir.
Yes sir.
All right. Okay, so actually to save the bandwidth, I am just turning off my video. All right. Is it fine?
Yes sir.
Okay, all right. Okay, so thank you, madam. And thank you, Aniruddha, for inviting me. And it is not expert talk. We are working together to develop some new technology or some new device or some new concept or technique for the future of our India or world. And at the same time, we also have to focus and take care of our environment as well. All right, this is must in the modern age, because we are using so many huge number of silicon material. So there is a huge amount of CO2 or emissions are there. We have to save the environment as well. So to take care of this thing only, we are shifting from traditional vehicles to the electric vehicles. All right. But what about the fact that if we will go for more electric vehicles, then impact will be on the grid, and ultimately impact will be on our fossil fuel storage. All right. And at the same time, as we know that electric vehicles will be having so many components like power converters, batteries charging, discharging, so many mechanical wear and tear devices. All right. And high frequency communication as well. So impact will be at every aspect, at every component of the grid. Maybe power system, maybe some IC engines, or those engines, or in the communication lines as well. All right. So to take care of this, we should know about the present status of electric vehicles and different challenges in implementing this concept in modern world. So I will just give you idea about present status, and then we will see some challenges in the EV market or EV sector. And then I will give you some research going on in my laboratory uh, for developing some new device, new concept in EV charging infrastructure. Because I'm the engineer from power electronics area, so my area is developing some good electric vehicle charging infrastructure and to see the impact on the grid. So in this part one, I will focus on electric vehicle present status and different worldwide challenges and progress. So this picture will give you about the early range of 1905, small electric rickshaw type of thing, and mid 1970s. You can see this thing. All right. So EV charging is not a very new concept. This was very old, around 1970s around, but that was not means in wide accepted in the market due to some problems because of lack of awareness, lack of good material for the battery, less efficiency as well, and very uh, cost was very large in that case. And now we are anxious about the range of the electric vehicle after one charge, single charge, and second is the storage and cost. So range anxiety and cost, these are the major things nowadays. So from this we know that US and Western European Union. So now US is dominating the percentage share for each region in hybrid electric vehicle market. All right, since starting. So just I have captured some figures from internet or from some sources. So those figures we should know about the present status of the electric vehicles. Because in the past means we were having some electric vehicles which were having onboard chargers, which were having so many features like this. But in modern age, what is the status? So by 2020, and around 10 million electric cars were on the world's roads. Now it is increasing tremendously day by day. Electric car registrations also increased by 41% in 2020. So these data are up to 2020. So you can update these data till 23. So despite the pandemic was down, even then 41% increase was observed in EV registrations worldwide. And global car sales were dropped by 16%. Even then, electric vehicle registrations were increased by 41%. So this is the interesting figure I have encountered on internet. So I would like to just show here. And around 3 million electric cars were sold globally. This is, you can say, 4.6% sales share. And Europe overtook the People's Republic of China as the world's largest EV market for the first time. Electric bus and truck registrations also expanded in major markets. Now we will talk about the resilience of EV sales in the face of the pandemic. Because during the pandemic, we have learned a lot of things from the nature, or you could say nature-inspired experience or learning we have done during the pandemic. Those 2 years, those 2 years were really very nice for all of us. You know, we have learned a lot. So the resilience of PV sales, you can say these will be having the three main pillars. Number one, supportive regulatory frameworks. So we have to take care of the CO2 emissions as well, and we have the responsibility to implement or to generate zero emission vehicles. So this mandate is required. So this policy we have to take care. And by the end of 2020, more than 20 countries had announced bans on sales of traditional cars or mandated all new sales to be zero emission vehicles. It is very required because we have to go for green grid or green energy or green vehicles. Additional incentives to safeguard EV sales from the economic downturn. So some European countries also increased their purchase incentives, and China delayed the phase out of its subsidies scheme. So these are few methods or ways by which they are trying to increase the awareness about EVs. So the number of EV models expanded and battery cost continued to fall. This is the major issue in adopting the EVs. Battery size, and in single charge, how much kilometers we can go, and the total time required to charge one battery. So slow charging, fast charging, these also we have to take care. Then out of the world's top 20 vehicle manufacturers, which represented around 90% of new car registrations, 18 have stated plan to widen their portfolio of models and rapidly scale up the production of light-duty electric vehicles. So now we can see, so all companies, all the big players in vehicle automobile sectors, now they are jumped into electric vehicles. More electric vehicles you can see, more electric vehicles. It is the correct term for this in modern day. So now the availability of heavy vehicles is also broadening, and major truck manufacturers also indicate all electric future. So there are three terms: electric vehicles, more electric vehicles, and all electric vehicles. So these are the three terms we have to take care very carefully. All right. Now, we can say that the spending amount from the consumers. So consumer spending on electric car purchase increased to 20 billion US dollars in 2020. All right. And in parallel, government is also providing some subsidy or some share to the market. So government across the world spent $14 billion to support electric car sales in terms of some subsidy or incentives. All right. Without that, it is very costly to adopt the electric vehicle. Okay. So these are some figures I have captured, and means we have to just review the existing policy in the market as well, and we can say EV market could be very significantly larger if governments accelerate efforts to reach climate goals. All right. So sustainable development scenario, the global EV fleet, it will reach around 230 million vehicles in 2030. It is expected. A stock share of 12%, it is a very large amount, you can say, of only two and three wheelers. It is not including that truck and heavy duty vehicles. All right. So in order to electric vehicles to attain their full potential to mitigate carbon emissions, these are few challenges we have to take care. To mitigate the carbon challenge emissions, critical progress is required to decarbonize electricity generation. All right. So we have to rely mostly on different renewable energy sources. And then only you can say we are moving towards green grid or green vehicles. Next challenge is to integrate electric vehicles in the power system. So we can talk about grid to vehicle, vehicle to grid type of power flow control. So we should be able to implement very good scheme or method or control logic to integrate EV into the power system, है ना? Without having trouble to the environment. And this is biggest challenge to build charging infrastructure. All right. So without having a large number of charging infrastructure or charging stations, it is a very difficult task to put more EVs on the road. So we have to develop some advanced sustainable battery manufacturing and their recycling. So what will happen if you will your battery will not be of any use? So you have to dump this somewhere. So recycling of battery for sustainable future is also a very big challenge nowadays. All right. So this figure will give the idea about the global electric vehicle stock by region. Here you can say China, Europe, US, and other countries. So China is dominating, then Europe, then US. All right. And others are increasing slightly. And these are the transport modes. Transport modes means you can say these passenger light duty vehicles, light commercial vehicles, and buses and trucks. So you can see here. So this passenger light duty vehicles are having major share in these type of electric vehicles. All right, and it is also increasing day by day. All right, this will go up to very. You can see the sharp rise in the graph. All right, so this will go into by 2030. You can imagine where it will go. This International Energy Agency, so they are working hard to serve as the coordinator to support EVI member governments in this activity. Electric Vehicles Initiatives, EVI. So this is worldwide agency which is controlling all the EVs implementations on the road. So every country has to follow some rules and regulations from this IEA. So governments that have been active in this EVI in 2021 period, they includes this Canada, Chile, and they are also in the list here. So big countries are there, and we are also in the team. Then Canada and China, they are co-leading this initiative, and Greece and Ghana are observers. So this is one information I got. So now we are having a great responsibility towards environment and towards EV development as per this IEA. All right. So this EVI will also help to raise the ambition levels for electric mobility worldwide through the linked CEM campaigns, EV 30 at 30. All right. So this is the global commercial vehicle drive to zero campaign with zero emission vehicle development, each endorsed by different member states or countries. So we have to go for zero emissions. This is the latest trend, because if you will search on the internet the literature available in electric vehicles, it is now mature now. It is completely mature technology now, EV. Now, so this in this area, electrical, mechanical, CSE, EC person, or maybe chemical also, they can do a great job here. So they all come together and they can do some innovative ideas. It is a completely matured area. Now we have to focus on some challenges like zero emissions, green vehicles, green grid, non-dependency on the traditional grid, battery technology, range anxiety, all right, charging time, and thermal management. It is a huge challenge nowadays because you cannot go without thinking. You will even not go for that fast charging. Every time fast charging is not suggestive. All right. So to take care of these, we have to do a lot of work in that. And Anirudh also doing the PhD in impact analysis of EV on the grid. It is very required nowadays. So this EV 30 at 30, this campaign was launched in the year 2017. It is the latest development, and it sets a collective aspirational goal for EVs to reach 30% sales share by 2030 across all these countries, 30 countries. All right. So this is a huge target by this IA. All right, IA. This is the benchmark against which progress is to be measured for EVI members. All right. So depending upon this, we can say that we have a big responsibility to implement these EVs, and now we have to focus on some goals and complete coordinated control by IAA. This campaign will include 5 implementing actions to help achieve the goal with the priorities and programs of each member country. Now, these few goals we have to achieve, these are, see, I think all the participants are from different institutes or industries. So they are doing their MPEX or PhD, or they are engineers, or some are also faculty members. So they can also work hard towards the development of some policies, some roadmaps, and some impact, or they can work on any of these actions to support and track the deployment of EV chargers. All right. So this will need a huge study and analysis in the market. I cannot give here all details, but briefly you can just note down all these points. We have to also focus on the galvanize the public and private sector commitments to incorporate all these challenges or EVs and company and supplier fleets, scale up the policy research and information exchanges, and we have to support governments through training and capacity building. This is much required nowadays. Alone, government cannot do anything. They can invest from the income taxpayers' money. They can invest on the infrastructure or some facilities, but we have to support them through proper training and capacity building. And this program, this 5-day program is one of them, I think. So it is ISTE sponsored program. So having major contributions from the industry as well. So this will play a big role in this point, I think. We have to also work on establishing the global EV pilot city program to achieve 100 EV friendly cities over 5 years. All right. So target is that over 5 years, complete EV dependent city to be developed. Very huge task. All right. So now they have also launched one EVI Global EV Pilot City program in 2018. So the meaning of providing you this data is that there is a lot of work or programs, schemes launched worldwide to support and spread the use of. All right. So this is not a big task to take these data, no problem. Now, we should know these figures. More than 10 million electric cars were on the road in 2020 with battery electric models. Now, question is that can we depend upon only battery, or we have to go for some hybrid electric vehicles? All right. So nowadays, battery is not a very reliable source. While you are running or driving the car on long run, suppose for example more than 500 kilometers or 600 kilometers. So on battery, you cannot rely completely. All right. So we have to go for hybrid electric vehicles in that case. All right. But how we can improve this reliability of the electric vehicles? So we have to go for more electric and all electric vehicles. So this graph will show the total number of vehicles available. All right. So China is again leader in that case. Now this will give the idea about the electric car registrations and sales share in selected countries and regions, 15 to 20. Again, increasing tremendously in China. US, you can see not up to that rate. Europe, tremendously from this near to 1920, pandemic was very huge. All right. So Japan, Korea, Canada, UK, France. So everywhere you can see Germany. Now you can see in Germany sharp rise in the electric vehicles registrations. And different models are available in a small car, medium car, crossover, then large car, SUVs in different countries. So you can see SUVs are increased in China tremendously. SUV. All right. And this will give the idea about the electric car models available globally and average range. Range is main thing. So number of available models and range in kilometers. So in single charge, you can say this in PHEV and BEV, battery electric vehicle. All right. So this range is there. All right. So by this, we can say up to 350 kilometers, we can go by single charge. Now the challenge is that how much time it will take to charge fully one battery to go up to that range. It is again big challenge nowadays. Now this data will give the idea about the fact that 18 out of 20 largest original equipment manufacturers, they announced some policies related to electric light duty vehicles like BMW, BAIC, then Daimler, then Ford, GM. So like this, these are giving some percentage of share electric vehicles, you can say, annual sales, new EV models, then cumulative sales. So now you can see here. So they are having commitment to increase the offer and sales of EVs. All right, and they announced some policies related to electric light duty vehicles as well. So by 2030, you can say BMW will give you this 10 cumulative sales in millions, 10 millions, you can say. 50%, this you can say, 50% sale of electrics by BAIC group. So you can see tremendous increase here. All right, like Volkswagen, 70% sales. So they are having a huge target set by 2030. So they are trying to increase the sale, and on the government it is a challenging task to increase the number of charging stations, without having adverse effect or impact on the grid. All right. So these are few challenging tasks we have to take care. All right. So this data is interesting. I found. So I would like to show you. This will give the private sector demand for zero emission commercial vehicles. And this will amplify the market signals for OEMs to develop electric vehicles. So now you can see these big companies, operating areas are also there in different countries. They announced they have some target sets, all right, in these years, and targets or actions to be achieved are these. For example, Amazon announced in 2020 globally to order around 1 lakh battery electric vehicles, light commercial vehicles from start company. Review. Amazon aims to be net zero emissions by 2040. Now see the target they set to be net zero emissions by 2040. It is a huge challenging target they have taken. Now orders up to 800 hydrogen fuel cell Nikola heavy duty trucks. All right. So they have set every industry, every company is targeting or setting big, huge targets. Now see this Walmart electrify the whole vehicle fleet by 2040. You know, so now you can imagine after around 10 years, you will have very less vehicles on the road having petrol or diesels. You know, so now the time is coming very soon. But big thing is that we have to go for zero emissions. You know, zero emissions. So take care while you will do research in this area. Take care of in the thesis, in the paper, in the patent, you write something on impact on environment on the grid. So impact should be very less on the grid. So this we have to take care. All right. So we have a big responsibility. You know? So without thinking, without analyzing, don't adopt EV or PV. You know? We should think on the impact on the grid or environment as well. CO2 emissions and zero emission policy we have to take care. So this will give the top 5 bad barriers or restrictions, you know, to EV adoption reported by EV 100 members. These are worldwide studies they have done. So 67% largest barrier is lack of charging infrastructure. You know? So because of this, we are only thinking that okay, we purchase one EV and we can also run in on a city. Don't go outside the city. So intercity transport is still a big challenge due to lack of charging infrastructure. You know? Then lack of appropriate EV type. Because so many companies nowadays are there, they are developing their electric vehicles and charging guns or socket or chargers as well to only cope up with their company's EV only. It is not generalized. So generalized electric vehicle charging guns or EV charging stations or electric vehicle as well or socket. It is required. Still, companies are not doing that thing. So there is no standard policy or rules. It is framing, but not completely framed in different states. So work is to be done to standardize or generalize the EV policy. Then third is capital cost of EVs. Again, big challenge. It is decreasing nowadays, and operational change impacts like charging time constraint. You know? So everybody will try to charge the battery within 10 minutes, 5 minutes, even less than that. But remember, you have to charge the battery as per the convenience of the grid. You know? Because just by making one policy that some incentive may be given to the customers who will charge the battery or EVs during the less peak hours or light load hours. Like this, we can do something. You know. So if you are using the fast charging method, then problem will be there. Stress on the battery will be there. You know. So stress should be minimized. Otherwise, this will create huge impact on thermal cooling of the battery. You know? So take care of this thing. Then uncertain or underdeveloped policy landscape for EVs. Still, we are lagging in this case. There is no policy, standard policy developed till date, common or standardized to all countries, to all states, to all vehicles. It is also a big challenge. So this is one point we have to take care. And next, present status of the electric vehicles is that automotive battery demand. All right. So this is again big huge challenge. New battery technology, new material for the battery that will give you more energy density, more power density, you know, and less corrosion also. So by taking care of this capacity also to be increased because you cannot spare huge space for battery in the car. All right. So the overall power density or energy density of the vehicle is to be improved. And this power or energy density you can improve by minimizing the size of battery, size of the converter, size of all the EV components. है ना? This we have to take care. And at the same time, you have to go for long kilometers, long duration, long range. Big challenge. All right. So now this figure will give you the idea about total number of this fuel cell electric vehicles. So we have to search some alternate for battery. So fuel cell is one of the alternate. So in this case, you can see fuel cell electric vehicles stock and hydrogen refueling stations by 2020. है ना? So in different regions like Korea, US, China, Japan, and Germany. So you can see these are having dominated this thing. Only in terms of fuel cell only. You know? And for this mode of transport, this light commercial vehicles or passenger light duty vehicles, buses and trucks. So nowadays, by 2020, each number of vehicles on for different modes or different vehicles, they are running already by fuel cell. So this is again a good source of fuel or fuel in the EVs. Other than this, you can also go for some new material like sodium ion battery or aluminum air or solid state battery. You know? So battery is having very good scope of research or work. And recently we can have that you can say redox flow battery, a vanadium redox flow battery. It is also having huge impact or good opportunity, you can say, in future, but it is having less energy density and this will consume little bit more space. You know? But if in the applications where you don't care about the space consumption, you can go for that vanadium redox flow battery. It is a good option. All right. Okay. So, all right. I'm just seeing the time only. So I think I have how much time more?
Sir, almost. You can speak up to your
All right. Okay.
whatever time.
All right. Okay. Okay. Thank you. All right. So now, because I have taken this data from internet, so this you can see the stock of fast and slow publicly accessible chargers for electric light duty vehicles. So these numbers are very less actually. As per the demand in future, the total number of EV charging stations worldwide are very less. All right. So if you will see the percentage sale of electric vehicles, so the rate of increase in EV infrastructure, charging stations is very slow, actually. So this we have to take care, this part. All right. So by taking care of all these, now we have to make some deployment policy for EV charging infrastructure. This is the very biggest challenge. Worldwide, all countries are facing this challenge. So we are having huge population or huge number of EVs to be coming on the road. So this is the biggest challenge in India. How to increase the number of EV charging stations. All right. Most charging of EVs is done at home in work. We know already. All right. Publicly accessible chargers reached around 1.3 million units in 2020, of which 30% are fast chargers. All right. But these are not having very huge rating. Very low rating only. Now, interest in publicly accessible chargers was up to 45%, a slower pace than 85% in 90. Now you can see, in respect to the in the electric vehicles, the percentage increase in the electric vehicle charging stations is not large. This we have to take care. All right. Now there are big companies, they are doing their best there. So China leads the world in availability of both slow and fast publicly accessible chargers. We have to work hard in this last point. We have to put more chargers. All right. Now, this data will give you some figures till now on slow chargers. Because my area is power electronic converter, so I will only work on this charger side. So slow chargers, the pace of slow chargers, charging power below 22 kilowatt, it's called slow charger. Installations in China increased by 65% to about 5 lakh publicly accessible slow chargers. You can imagine this. We are very far behind this figure. All right. This represents more than half of the world's stock of slow chargers. You can see China is having more than half of world's stock of slow chargers. Because we are depending upon China on so many components, even for EV also. Not only magnets, but silicon chips, ICs, PCBs, and a huge number of components we are depending. Now, scenario is changing now. We are trying to self-dependent ourselves now. Europe is second with around 2.5 lakh slow chargers. All right, 1/3 of the total. Then Netherlands with more than 63,000 slow chargers. Then Sweden, Finland, Iceland, Ireland, this doubled the stock of slow chargers. Then US now see slow chargers in US increased by 28% from the prior year of 82,000. All right. In Korea, you can say 45% in 20 to 54,000 in second place. So now these figures, so you can say China, Europe, US, these are the big players now. Now come to the fast chargers. If you are having the capacity more than 22 kilowatt, then you can tell it is fast charger. In China, you can say increased by 44%, 3.1 lakh fast chargers, slower than 93% pace of annual growth in 19. All right. So second, you can see in China, to compensate for this paucity of private charging options and to facilitate achievement of goals for rapid EV development or deployment. In Europe, fast chargers are being rolled out. Just take care of the sentence, this point. Europe is rolling out the use of fast chargers at a higher rate than slow ones. All right. Now think over this point. Why they are rolling out this thing? There are now more than 38,000 public fast chargers, up 55%, including nearly 7,500 in Germany and 6,200 in UK. Like this. US around 17,000 fast chargers, of which 60% are Tesla superchargers. Korea, this much figure. All right. So publicly accessible fast chargers will facilitate longer journeys. As they are increasingly deployed, they will enable longer trips and encourage late adopters without access to private charging to purchase an electric vehicle. All right. So now you can see the figures of slow charger and fast charger. So this, we can summarize that when you deploy or implement slow or fast charger, depending upon the customer requirement. Again, from this answer that always fast chargers are not good for the life cycle of battery or vehicle. So can be same charging for half an hour or more than that and enjoy the ride without having trouble in the battery, without giving the trouble to the battery. All right. So you should treat the battery as one of your family member. So don't put more stress on that. So that it will not heat up. So its brain will not be heat up and it will not make you trouble. So by taking care of these points, we should think on which charger we have to implement or deploy. Okay. So this is the end of my part one. So quickly, I will conclude this part two quickly. Before that, if any questions, we can discuss now. Any questions? Till now, we can discuss. Otherwise, I will go to part two. Okay, I think no questions. So I'm just moving towards part two now. So this I will quickly give you. This is giving you some idea about the research going on currently in my laboratory, in my group, basically on development of solid-state transformer, SST, or you can say smart transformer, or power electronic transformer, or PET. This is the future of the grid, and we will study about the compatibility of SST with future grid. So this SST is nothing but it is having one transformer working at high frequency around 100 kilohertz, so that the power density will be very increased in this case. Before that, we have to see the drawback of the traditional transformer working at 50 hertz. There is no voltage or frequency regulation in the transformer available, no DC port available, and having large weight or volume or less power density. So these are few drawbacks of traditional 50 hertz transformer in our power network. All right. So these are the features in the modern area, or you would say smart grid. These are some features desirable in modern days, where electric vehicles, PV, battery, DC loads, LEDs, है ना? Or you can see more DC loads are there. Nowadays, you can see majority of the loads are DC, maybe fan, motor, chargers, computers, PC, LED, TV, washing machine, everywhere. You know? So now we are moving towards more and more DC loads. So there is no DC port available, you know, in transformer available. So we have to develop some device or equipment which will be giving you DC port inherently available, and we should develop something which will give you ease of integration of distributed energy resources like PV, wind, or other resources. And there should be high or medium frequency isolation also in modern days, because you are using huge number of DC to DC isolated converters in so many applications like SMPS, UPS, power supplies, you know, like this. So we have to provide some isolation at that level and low weight or volume. These are few features. And to protect the sensitive loads from power system disturbances, from voltage harmonics, sag, outage compensation, and LVRT capability. So these are the uneven or abnormal conditions from which we have to protect our power network as well. Because all the features will be more prominent if you will talk about electric vehicles type of highly non-linear loads, unpredictable loads. You don't know about how many EVs will be connected to which charger. You don't know, है ना? To different location of the world. And because now we are talking about the global grid, some concept is there. Global grid. All power stations in whole world will be interconnected. How it is possible? So you don't know. So you should know accurate knowledge about the total number of electric vehicles or PVs or different source or loads worldwide, so that you can control your local grid. है ना? It is required in future global grid. Protect the power system from load side disturbances like voltage control through VAR compensation, then distorted current by nonlinear loads, overloads, and fault current limiting and fault isolation. These are few things. Now, yes, anybody want to ask something? Maybe by mistake. All right. So these are the desirable attributes of modern grid: high controllability, high efficiency, high power density, and superior reliability. So these things we have to take care, है ना, in modern grid. Who will give you this achievement? है ना? So you have to use fast acting fault tolerant topology of converters, so that under faulty condition, customer will get full power with good power quality. We should develop some modular components for the grid, design of high frequency operation to improve the power density, because we know that the transformer or magnetics is the major component of EV chargers or components. So core size will be reduced if you will operate the core at high frequency signal. Then design optimization, loss minimization, and some new control strategy for real-time control and monitoring of the variables. So these you can develop. So SST is nothing but this is having this topology. AC you can take from the grid, then rectify this, then again invert this to high frequency AC, and then rectify this to DC. Second DC you can get and invert to AC. So this system is known as the state transformer with some features. So these are some features available in SST: high power density, instantaneous voltage regulation, power factor correction, outage compensation, fault isolation, DC ports available, because here you can see DC ports, one DC port and second DC port available here. Then power quality improvement, monitoring, control, easy integration of DC that loads or source like RDS, you know. And because we were using so many power controllers like DSP, FPGA, microcontrollers to control these converters, so it is very easy to interface with all the communication lines or smart network or IoT devices. And most important, we are able to control the power, active and reactive, in both directions very easily in this SST. All right. So quickly, I will just conclude this. So SST applications are broad, very broad. Fast charging stations, onboard shape, in the aerospace industries, traction drives, solar park, wind farms. So you can see this SST is having huge scope of applications in so many areas, where you will require all the features just mentioned before few slides. So this smart grid is having all the DC loads, sources, and smart communication, IoT devices, you know, smart monitoring, controlling, observing, data logging, everything. So this SST is the future of our smart grid. So there's a huge scope of work in this part. All right. So in the laboratory, we have developed one 4 kilowatt SST for some multi-port charger based upon this concept that we can develop 2 ports to charge up to different, you can say, vehicles, AC grid, then front-end converter rectifier, then DC converter here with high frequency isolation here, DC to AC converter, interfacing with the backup DC-DC converter or EV charging stations. This is called SST. And quickly, I will just come to yes. So this is the internal part of SST. Rectifier, then this is called dual active bridge. Inverter. So this rectifier will work at 50 Hertz, and this inverter will be having silicon carbide or wide band gap devices like SiC or GaN devices. Frequency of switching will be around 100 kilohertz in this converter. So this voltage will be having 100 kilohertz around high frequency voltage. So the core size of this will be reduced tremendously, and this signal is again rectified to DC. So these two converters are having wide bandgap device like SiC or GaN, MOSFET or IGBT. All right. And again, invert this to AC to connect to AC loads or to other AC grid. So you are having one AC voltage level, second AC level voltage. So different AC voltage integration you can have. All right. DC level 1 and DC level 2. So 2 DC ports available at 2 different voltage levels. So now you can integrate your photovoltaic outputs or battery of different ratings to any of these 2 DC ports. All right. So this is, you can say, 10 most emerging technology by MIT in 2010. So this on SST research was done or increased during last around 13 years. Before that, research was going on, but at very slow pace. Because in this, the main advantage is the use of wide bandgap device. Without that, no use of this high frequency transformer or these converters. All right. And the development of new devices in the power electronics switches like silicon carbide, gallium nitride, only it's possible. Otherwise, you can ask one question that it is having more converters, so the efficiency is reduced as compared to the traditional transformer. है ना? But I can tell you that having sick organ devices, this will give very negligible switching losses in this case. And second thing, power density is very high, and you are getting more additional features. Although the efficiency is not at par with traditional transformer, 50 hertz transformer, you know, it is not 99% or something in industries. But this is giving you a huge number of additional features for the taking care of the future smart grid. So that's why you cannot miss compare anything just based upon the cost or price. You should also see the features, quality, and convenience given by the product or some concept of research. All right. So in the laboratory, we have developed this simple, you can say, SST, having one rectifier, one high frequency inverter topology here, having two different isolated high frequency transformers here, and two separate ports are available here. So based upon this topology, we have developed in the laboratory. My student Deepesh has developed this thing in the laboratory to develop two ports of 400 volt each to charge two different vehicles. So different modes we have done. One challenging task we have faced is that in this charger, this topology or this voltage conversion ratio is one major challenging task which we have to take care. है ना? Stepping up or stepping down is required. So voltage conversion ratio is one challenge. All right. So this is one task we can control. And in this case, we have to control the phase shift angle between this S1 switch and S1 dash switch. All right. So this will give that idea. Yeah. So this phase shift angle control we have to take care. So that will control everything. Right. So this gain with the duty cycle we can control. And this is the operating areas. I would not like to focus more on this. Yes, then this part, soft switching range, we have to improve. In all the charges, to improve the efficiency, we have to work on the extension of the voltage conversion range and soft switching range as well. Because your circuit will not work perfectly for any voltage ratio or any soft switching range. This will to take care, and design of the inductor or transformer is again big challenge here. So take care of the parasitic elements in this design of the components. All right. So the traditional formulas are there to design the inductor or transformer. Then improve the gain and quality factor for the range. You can use some different topology like full bridge or half bridge. So they will give you different gains. So depending upon the requirement, you can adopt any type of topology for that. So DPS has developed this inductor in the laboratory and this transformer in the laboratory also of different value and different turn ratio. This is the hardware model developed already in the laboratory, having different components, and ratings are there for 6 kilowatt. So we have captured some good results also. So this is giving you the perfect ZVS also, and you can see that automatically controlling of the phase shift is also there. So phase shift angle control will be also there here. So the phase shift angle between primary and secondary voltage will also be visible. All right. ZCS and ZBS are achieved perfectly. So this is having highly technical things. So this will again take another 1 hour. So time is not there. So just giving you only one idea. We have developed one new dual degree control scheme to optimize the performance of this SST. All right. So this is completely adaptive type of control logic, so that depending upon the load requirement, the phase shift angle phi will be adjusted automatically from 48 to 22, depending upon the load decrease or increase somewhere. All right. So this adaptive control logic we have developed, and quickly I will summarize this thing. This SST is nothing but this is the component which will be able to connect any distribution grid with fault isolation device, and this will be giving you one separate AC bus and one separate DC bus here. So you can integrate storage, photovoltaic, electric vehicle chargers, and AC loads at the same time, and all are isolated and reliable, having high power density. So all these features of power management, auto management, energy management, and DSM, all these will be taken care by the controller in this SST. All right. So in India, what we have to focus more. So in Indian market, in EV market, we have to we can see that this is on a rapid growth trajectory, and we are setting our ambitious targets to adopt the EVs. All right. So take care of environmental issues by reducing the air pollution, reducing the noise pollution, and improving the system efficiency. And then see the economic opportunities for India. All right. So some can do research on this analysis as well. Now the challenges in India to adopt EV are lack of clean energy. So we have to rely more on RES or clean energy like PV or wind. Yeah. Now you think PV is also not a clean. It is using silicon. Disposal of PV is biggest challenge, or damaged PV panels is again biggest challenge. Then underdeveloped charging infrastructure, suboptimal battery technology is also one challenge in India. Then persistent resistance to change, biggest challenge. We are not ready to change ourselves. You know, we are reluctant for any change. All right. So we have to learn a lot from other countries as well. So by 2030 in India, target EV to standard car mix now. Buses 100%, commercial vehicles 70%, private cars like this. All right, and two and three wheelers like the 80%. So this is the target set by Indian government by 2030. You know, all buses should be electrified like this. You know, so we are having huge responsibility. So we have to do research which should be useful to the society and to the environment as well. So all these are my research team. They have worked hard. All right. So this is all I would summarize my discussion. Now, any questions? Now we can discuss now. If anybody want to ask, now floor is open to all of you.
Sir, what is the capacity of the solid state transformer available in form of power transfer capacity now?
See, this SST is not available in the market. ABB and some companies are giving that, providing that, but still it is in R&D phase and in the laboratory. In US, it is used in ship propulsion system and some big industrial power supplies. And that rating is around, you can say 100 kilowatt, not more than that. It is the biggest rating of SST in US, 100 kilowatt. and they are working at around 40 kilohertz switching frequency in that. In India, only few are working, like IIT Madras and Roorkee, and myself, and Bombay is also doing something. I am developing a 25 kilowatt charger, multi-port charger, under some project. Yes. Manaswi is asking something. Can you elaborate more on voltage ratio on primary side and secondary side? Okay. See, as I told you, Manaswi, that voltage conversion ratio is biggest challenge, because you have to design your inductor or transformer or all the magnetics to take care of some defined range of the voltage conversion ratio. All right. So this is limited actually. So this you can enlarge or extend by having proper designing of the inductor. This is again main challenging task. And second thing, you can also work on this by having proper or optimized control of switches. As I already just a bit, I will go to slide number 55 now. 55, yes. So here you can see. So here you can see, in this case, voltage ratio will be 0.4 up to 1 and 1.1 or more than this. So you are stepping up the voltage. So 1:1 ratio is giving you optimized performance with complete soft switching. This is the main thing. If you want to increase this ratio, then your system will go into hard switched mode. In that case, you have to again optimize the switching frequency, a duty cycle, and third is the, you can say, a phase shift angle. All right. So there are 2, 3, or 4 variables: voltage conversion ratio, duty cycle, phase shift angle, switching frequency. All right. And again, inductor design. So these are few parameters need to be optimized. If you will improve one parameter, the other will deteriorate. You cannot satisfy all the parameters. Never. You cannot do that. Manaswi, I hope you got the answer. Or you can unmute and ask. Hope you got that. Yes, any other question?
Hello, sir.
Yes, Sakib, yes.
Sir, is it really achievable? Like we have said, that target is 100% electrification of buses, like 70% electrification, because it's already 23 and it's nowhere close.
Yes, see, it is target. Always from schooling to till college or till life end, we should set very high target. We will try to achieve that. Then 100% maybe we can achieve 80% maybe like this. So nobody can tell that they achieved the 100% target. They have set it before 5 years. Nobody can tell that. No industry can tell that. So they have to keep some margin for that. It is a very difficult task, but still we have to try hard for that. That's why we are conducting such type of workshop or something, or brainstorming sessions worldwide, so that people will work hard to achieve that target.
Right, sir. If there is work, yes, they will try to achieve it. Right.
Yes, yes. If you will target for 50%, then how much you will achieve?
Yes, very less.
So set very high target. Sky is the limit.
Yes, sir.
Am I audible to you? Is there any questions from participant side?
Hope everybody got something from this, so that they can.
We really got quite, knowledge in depth, actually. Practical knowledge, I would say.
I have corrected and delivered something to you.
Yes, sir.
So,
Yes, sir. We have actually got a lot of in-depth of it. Thank you very much.
Okay, thank you so much. It is my pleasure that you are appreciating this thing.
Hello, sir.
Harish, yes.
Sir, in SST, DAB, that rectifier and inverter is used. In that, what was used for giving pulses?
Okay.
Which DSP?
No, in that case, we can use you can use any controller, any microcontroller or FPGA or DSP. But you need to generate high frequency switching pulses. So better to use some FPGA board, which will be having high speed with less operational or controller losses. So FPGA is best, but DSP 28379D is or 28335 is also good to generate the pulses for that.
Thank you, sir.
So, thank you so much, Mr. Chaturvedi, sir, for taking your time to guide us at our event. Sir, कहा जाता है कि well begun is a half done. So our beginning was very well done, and we are so glad to have you here. So your insights and perspective were truly valuable to us, sir, and we were all thoroughly engaged by your knowledge. It was a pleasure to have you with us, and we really enjoyed this experience. We would love to hear you again in future, sir. Also, you have reminded us one more thing, which I believe, एक विश्वास हो गया कि that you really implement this thing, which I will also try to implement in my life, that you should, sky is the limit. You should always set your goals to the maximum value. So
Yes.
you have reminded definitely going to I'm definitely going to try to at least implement in my future, sir. Thank you so much, sir. Now
Yes, thank you so much. Thank you so much for inviting me. Okay, thank you so much to all the participants, audience, and the organizers to invite me and listen patiently till the end. Thank you so much.
Sure, sir.
All
Sir,
right, okay.
I would like to request all the participants to kindly switch on their camera so that we can save our memory together by having a photograph with our honorable speaker, Mr. Chaturvedi, sir. So everyone, please switch on your camera.
Okay, I can see Snehal madam is also there. Hello, madam.
Okay, sir. Thank you so much for your valuable time. And thank you so much, participants. One request to all of you, dear participants, attendance link have been already posted in the chat box. Please don't forget to mark it. Thank you, participants, for your patient hearing. Now we will resume our session sharp at 2 p.m. Session 2.